Okay, I'm working on this DC radio and evaluating this area here. And of course I haven't cleaned it off yet, but that's okay. I got this where I can at least turn it a little with the shaft. And you see what's going on there. And the string, you see how it wraps around. It's tied here to a little spring. It wraps around one time, comes down, goes around this one, and connects to here. The other side of the string comes around and connects to the bottom of this post here that's all the way extended down. In order to pull that up, I have to readjust this because this is wrong, so that I have enough slack there to lift this up into the cylinder where it belongs, and then I can tie it back to this one. But in the process, I was also checking out these coils. This one has nothing connected to it, so I have to figure out where those two wires go. It looks like this one might have been soldered here, because there's two, and this one has solder on it. I get my light out of the way there. And so, of course, like I said, I got the wiring diagram and I got the layout. Ironically, when I check from here to here with my ohm meter, I get no connection, and I think I see why. It looks like the wire is broken off. There it is. So I got to reconnect that wire, most likely. I'm sorry, that wire there. You can see it there. I don't know if you can see that little wire there. These are hair wires, most likely connected here. So I wasn't getting a reading across this. Well, now I see why. But this one, which is missing the brace, see this vertical piece of like cardboard, Bakelite. I guess it's cardboard, could be Bakelite. I think it's the same material that this is made out of, some kind of cardboard. Has notches in it, top and bottom, here and down there, that hold this close on that coil. Well, this one's missing, it's totally gone. And this came off the coil, was flopped way up here, as you can see in the previous part of the video. But ironically, the wires didn't break. They just pulled a few loose rings of coil up. So I put it down and I got it back centered, and I put this rubber band on it, which should now allow me to be able to pull that cylinder up if I can get the slack off. So I'm probably going to unwrap this, try to get that up there, figure out where these wires go on this little coil, which I'm thinking probably this end connected here, and that end might have connected up there. I don't know, but I got to find that out and get them connected, and then reconnect the bottom of this coil, which I think just solders there. This whole area has been abused, so not just by weather, but obviously something broke all these little wires. So I'm hoping that wasn't somebody working on it and really messed it all up, but we'll figure it out best we can. Once I get that done, I got the tubes, and put the tubes in and build and get the batteries to go ahead and energize it. And then I'll have to get the oscillator here and the tuning capacitor here, and the string on the front for the pointer that goes across the dial lined up. But I'm not worried about that. I'm more worried about right now about getting this where it's functional. When I turn it, they go up and down, so that I can go ahead and get it tuned for a station. That wheel here was really close to this shaft of this coil here that's not connected, and it was actually hitting it So this is like bent a little. I screwed that coil in. I'm hoping that I can leave it in a little, and if I have to screw it in or out, I might be able to readjust that with a capacitor or something. I can't get this wheel off. Somebody stripped out both of those Allen screws. They're very small, and I can't even get pliers in there to grip it and try to break them free. I put oil on them, but to lubricate them, to try to break them free with the Allen wrench, but it just won't do it. And it's a very small Allen wrench, so it just slips. Anywho, and you can see these coils have also got a lot of dirt in them. These cans, both of these IFs, they got a lot of dirt in them. I'm hoping I can just blow that out without having to disassemble that, because it looks like those things could break off. But we'll deal with that once we get it going. So anyway, I just wanted to show this part of the video and also document how that string is wrapped around, goes counterclockwise around that spool from the spring 2 times, it looks like. And I'm not sure, maybe 2 strings, probably 2 strings in there. Let's see if I can see. Yeah, that looks like 2 strings. One going clockwise, one going counterclockwise. It is. And one feeds this cylinder and one feeds this cylinder. Oh, tuning coils. So anyway, that's where I'm at. Thanks for watching. Okay, here's where I'm at. This is my battery pack for the B+. I've got 9 batteries in series here and 2 battery 9-volt battery clips to come out. That side I'm using the negative, this side I'm using the positive, and it's 88.4 volts. I had 10 batteries and it was 98, and so I didn't want to put that much voltage in it at the get-go, so I'm just using 88, which is plenty. I haven't connected it to the circuit yet. I got the tubes installed. But what I want to do is, obviously, I checked the coil's fine, output transformer. What I want to do now is, these are the speaker wires connecting to the speaker in the box over there. I know this capacitor is bad, but I'm going to disconnect it. We're going to check it. It's only a 10 microfarad at 150 volts, which is amazing to me that it's so huge. That's just unreal. Let me see if I can get that better on there. Okay, so we're going to clip one in and do a test on it. And it's got some long leads, and I'm sure it's dry. So we'll clip the hot side off here and leave a wire so we can get to it. Okay. So this should be 10 microfarads. This is the positive side here. And so let's connect it up. So we'll take this off our battery, put it on the capacitor leads. Take this -1, put it on there. Change this over to capacitance. Try to get that where you can see it. There we go. $32. Oh, look at that. It's jumping all over the place. Wow, that capacitor is really dead. So we're going to just bypass it for now. I'm just going to splice one in, and that way we don't have to worry about no hum. That's the filter capacitor. So I'm going to splice one in. We'll bypass the hum. Oh, hold on a second. That's not connected. Try that again. Okay, well, it's 30 microfarads. It's supposed to be 10. So it's 300% of what it should be. Anyway, we're going to go ahead and splice in a 10 microfarad at whatever I got. I probably got some small ones. And we'll just cut that one right out of circuit and jump in with a new one. And then, not going to worry about the wax capacitors right now. There's no sense in it. They may cause problems, but there's only a couple. And if they don't cause problems, at least we should get some sound. Don't have the tuning working yet anyway, so we're not going to get nothing other than noise, but we should get something, check the amp, and maybe run a IF signal through and see if the stages are working. So bear with me as I connect in another capacitor. Okay, I connected this 10 microfarad at 450 volts capacitor in circuit. Well, not in circuit, I'm across my meter. That one was 10 at 150. This one's 10 at 450. It's overkill. It's a lot bigger than it needs to be. Look at the difference in size. And yet this thing is a 450 volt one. A 150 volt one, like what's in there, would be so small. And this one is 9.94, 9.95. It's right at 10, a little under 10 microfarads. So I'll go ahead and connect that one in. Okay, and here is my filament battery, 1.5 volts, and it's giving me 1.648. So these batteries are brand new, obviously. They're 1.5 rated. So I got my 90 volt B plus and my A battery for the filaments. So I'm going to hook them up and we'll see what we get. Okay. Still working on this radio. I got it recapped, put the electrolytic in, ran all the new caps. It's short on 0.004 caps, but that's okay. I just put a 0.002 and a 0.003 together. Actually, the schematic calls for 0.005, and within tolerance it's up to 0.006, and I'm just a little bit over 0.005, so I'm fine. I'm well in specs there, and got them together. I doubled up the resistor there. Didn't have to, but I wanted to just make sure that I had a half watt of capability. Didn't need to, but I just figured I would. So because those are 10 meg ohm resistors, they'll never see a quarter watt, but I figured let's be safe. So I believe in overprotecting, and so I did there. And now what I did is I got a signal coming in across a capacitor from my radio, which is playing, by the way, into this radio connecting to the volume control. And it's a weak signal because it's going through a 0.002 capacitor back here, coming in from the jack on my radio, the output jack, which is a earphone jack. So it's very low voltage. It's very small. I added another battery to the battery pack, so I got 10 9 volts, which gives me 95.3 volts, 95.4 volts for B+. Actually, when I turn that on, it'll probably drop to around 89, which is about what it should be. And I've got this multimeter connected to in circuit with the battery, the B+ battery, in order to monitor the current draw on the B+ line. 2 flashlight batteries are connected to the filaments of the tube, and they light up the tubes. So I haven't fixed the broken coil yet on the tuning capacitor. I just wanted to recap it and see what we got here. So here's what we got so far. If I turn the power on, you'll watch the voltage will drop. Okay, so it dropped to 88 volts, which is fine. And we're drawing less than 10 milliamps of current through the B+ line. So there we go. Now I can't can't leave it there because of copyright. Let's see if we can find another station. I just tuned it off stations. I'm tuning my little radio that's driving this. Let's find some talking. Okay, there you go.
2 and 3 in San Francisco. While the Senate was hashing it out, among Republicans like Kevin McCarthy were working it out. Now she's saying we gotta not delay and just spend another $2 trillion.
So we got plenty of power through the amp. So right now what I'm doing is going through the volume control. It goes into the grid of the first amp detector, and then comes out of that preamp into the amplifier and out to the speaker, and it's driving that big old speaker with 9 milliamps current.
On the way out the door in 2016,
and when I turn my meter back on, that was that beeping, it was just shutting off. You see, we're still got 87 volts. So 90 volts worth of batteries, and I'm pulling 87 volts under load. That's awesome. And you can
the people want to go back. The numbers are getting to a point where they can, and there just seems to be no effort on certain blue states to get back into gear.
So we got plenty of power coming through the amp. The next thing is for me to hook up my generator, signal generator, and we'll start working back toward the front of the set, toward the tuning side, and check all of the IF cans and everything else. So I'll hook up the signal generator and we'll see what we can do there. Be right back. Okay, I got a signal going through it, and I backed up from the first IF to the second IF, and I have very high volume on the second IF, and now I backed up to the antenna, and I just tuned the first side of the first IF. So I had done these 3 from the grid of this tube, plate of this tube, and then this one I did from the antenna, of course, and I got a nice strong signal, 1000 hertz, and I can already hear, while it was doing that, I could already see now I'm getting life out of the tuner here. Of course, you know, these wires are broken, I gotta fix them. But I'm getting life out of the antenna input. So, we're making good progress. I'm going to shut it off so I don't kill my batteries too fast, but that's the next thing, is getting that ready, and then build the battery replacement unit, and then I should be able to get plenty of stations through this once I fix the tuner. So that's where I'm at. So we got good progress going through. Actually, I can, well, you'll see when we get further along. Thanks for watching the video. If you found this useful, please consider giving it a thumbs up. And I will continue this in a part 2 or part 3 as we continue working on this radio, part 3, I believe it is. So if you found it helpful, please give it a thumbs up, and subscribe if you feel like subscribing to my channel, and I appreciate whatever support you provide. Thank you. I went ahead and connected the signal generator back into the grid of the detector tube, oscillator tube, so you can see how it's working. Still got to clean this volume control a little bit better, but you can see I got a good strong signal, and on the scope I'm in really good shape. Okay, plenty of signal, nice waveform, so great sign. waveform. So there you can see that it's just a matter now of fixing the tuner section, tuner section, so that the oscillator and the mixer is working fine. But we'll get that taken care of next. Everything's tuned. The IFs are tuned for what I did by changing the capacitors. Whenever you change capacitors, you have to do another IF alignment. Because all of the voltages changed, the resistances and impedances all changed. So anytime you change components, especially doing a cap job, always realign the IF tune, IF cans, do an IF alignment. That won't affect doing the tuner alignment, which we will do later, the tuner oscillator and for the dial indicator and all of that. That happens separate from IF alignment. So got that done, and it's sounding good, plenty of volume, and didn't put too much drain on my 9-volt batteries. I probably could run it all day before I drain them down, but I didn't want to kill my batteries. But that shows how you can build a battery pack using 10 9-volt batteries and 2 flashlight batteries, probably 2 C batteries, but 2 flashlight batteries will handle the draw. According to the schematic diagram here, the filament draw drain is 0.25 amps. That's why you got to have flashlight batteries. They can produce that. You can't do it off smaller batteries. They got to be big. AA's, AAA's, not going to work. C's might provide that. They might provide a little less. Double D's definitely provide it when there's at least 2 in parallel. Now, 1 won't provide it, but 2 in parallel will. The B plus drain is 14 milliamps or 0.014 amps. So 9-volt batteries can deliver that kind of current. So that's your B plus drain on the 90 volts of 9-volt batteries. And there's a list of the original batteries that were designed, that this unit was designed to run on. Burgess 17 GD60, General 60, DL 11L, Eveready 748, or Rayovac AB 82 type battery packs. Those were huge. I'm running this on little 9-volt batteries and 2 D cells. So you can see that radio will work on batteries, just over-the-counter batteries with no problem. All right, thanks for watching.